Will astronauts traveling to Mars remember much of it? That's the question concerning Californian scientists looking at a phenomenon called space brain. They believe astronauts on deep space missions could suffer from dementia and permanent memory loss as cosmic rays bombard and damage their brains. Scientists have dubbed this space brain and say it may leave astronauts them anxious, depressed, paranoid and more likely to make flawed decisions. This study looked at exposure to highly energetic charged particles in rodents. This resulted in cognitive impairments and dementia. This study by University of California, Irvine follows previous research that showed somewhat shorter-term brain effects of galactic cosmic rays. Professor of Radiation Oncology Dr. Charles Lamolli said, "This is not positive news for astronauts deployed on a 2 to 3 year round trip to Mars. This space environment poses unique hazards to astronauts. Exposure to these particles can lead to a range of potential central nervous system complications that can occur during and persist long after actual space travel, such as various performance decrements, memory deficits, anxiety, depression and impaired decision-making. Many of these adverse consequences to cognition may continue in progress throughout life." The study involved subjecting rodents to charged particle irradiation, fully ionized oxygen and titanium, at the NASA Space Radiation Laboratory at New York's Brookhaven National Laboratory. They were then sent to Professor Lamolli's laboratory and examined 6 months later. The mice had significant levels of brain inflammation and damage to neurons. Scans showed the brain's neural network was impaired through the reduction of something known as the brain's dendrites, a short-branched extension of a nerve cell. There was also a reduction of spines on these neurons, which disrupts the transmission of signals among brain cells. Tasks designed to test learning and memory also showed the space brain had a negative impact on behavior. In addition, the radiation affected fear extinction, an active process in which the brain suppresses prior unpleasant and stressful associations, as when someone who nearly drowned learns to enjoy water again. Lamolli said, "Deficits in fear extinction could make you prone to anxiety, which could become problematic over the course of a 3-year trip to and from Mars." He added these 6-month results mirror the 6-week post-irradiation findings of a 2015 study he conducted that appeared in the journal Science Advances. Similar types of more severe brain dysfunction are common in brain cancer patients who have received high-dose, photon-based radiation treatments. In other research, Lamolli examines the impact of chemotherapy and cranial irradiation on cognition. While dementia-like deficits in astronauts would take months to show, the time required for a mission to Mars is sufficient for such impairments to develop. People working for extended periods on the International Space Station, however, do not face the same level of bombardment with galactic cosmic rays because they are still within the Earth's protective magnetosphere. His work is part of NASA's Human Research Program investigating how space radiation affects astronauts and learning ways to mitigate those effects. He added the findings could lead to spacecraft designed to include areas of increased shielding, such as those used for rest and sleep. However, he warned these highly energetic charged particles will traverse the ship nonetheless and there is really no escaping them. Preventive treatments offer some hope and his lab is working on pharmacological strategies involving compounds that scavenge free radicals and protect neurotransmission.